We will calculate with the classical arguments a la Rutherford the cross-section of a small nucleus of charge lowercase z scattering off a heavy nucleus of charge capital Z. The basis of this calculation is the relationship between the differential cross-section and the dependence of the impact parameter b from the scattering angle theta. First, we use the fact that the kinetic energy is conserved and that, as there is no recoil of the target, the initial and the final projectile velocities are the same. In the same way, the angular momentum will be conserved, which tells us that mvb is a constant. This means that d gamma dt can be expressed in terms of the initial velocity of the projectile, the impact parameter, and the distance squared between projectile and target. This serves to express the Coulomb force, which is just the product of the two charges divided by 4 pi r squared times a unit vector which connects the projectile and the target in terms of what we know, that is to say, the projectile velocity and the impact parameter. When we integrate this relationship between gamma equal to 0 and gamma equal to pi minus theta, one side is the vector difference between the final and initial velocities. The other side is the integral over the relationship we just obtained. With a little trigonometry, we get, rather painfully, the value of this integral. In particular, we obtain that the integral of the unit vector between the initial and final states is equal to 2 cosine theta over 2. On the other hand, simple trigonometry gives us a relationship between the length of the vector differences between final and initial velocity and the scattering angle, which turns out to be 2v sine theta over 2. The two relationships together finally give us the relationship between the impact parameter and the scattering angle we have been looking for. We then insert this result into our formula for the differential cross-section. After some simplification, we finally obtain the Rutherford formula for the differential cross-section of the process. It tells us that there is a very steep angular dependence inversely proportional to sine to the fourth theta over 2.